Hi, my name is Aloho and I'm a graduate of MIT. This video is on acidity and basicity, part 2. In part 1 of the acidity and basicity concept video, we discussed the definitions of acids and bases, as well as the acidic and basic properties of water, including an introduction to the pH scale. In part 2, we'll discuss the pH scale in detail, as well as buffers. As already mentioned, pure water contains an equal concentration of hydrogen ions and hydroxide ions. At 25 degrees Celsius, the product of the hydrogen ions and the hydroxide ions concentration in an aqueous solution is equal to 10 to the minus 14. This means that in pure water, or a neutral solution, at 25 degrees Celsius, the concentration of hydrogen ions equals the concentration of hydroxide ions, which equals 10 to the minus 7. This is because 10 to the minus 7 times 10 to the minus 7 equals 10 to the minus 14. If the concentration of hydrogen ions is greater than the concentration of hydroxide ions in a solution, then that solution is considered to be acidic. If the reverse is true, that solution is considered to be basic. The pH scale uses the concentration of hydrogen ions to assign a value that represents the level of acidity or basicity of a solution. pH is defined as the negative log base 10 of the concentration of hydrogen ions in a solution. So back to our neutral aqueous solution at 25 degrees Celsius with equal concentrations of hydrogen ions and hydroxide ions. The pH equals negative log of 10 to the minus 7, which is what the concentration of our hydrogen ions was, and also our hydroxide ion, because it's a pure water solution and the concentrations of both ions are equal. So that means that the pH of this solution, this pure solution with equal concentrations of hydrogen ions and hydroxide ions, is 7. And this is the pH of neutral solution at 25 degrees Celsius, 7. From there, the pH will decline as the hydrogen ion increases. The pH scale itself ranges from 0, which is the most acidic, meaning it has the highest concentration of hydrogen ions, to 14, which is the most basic, or the lowest concentration of hydrogen ions. And the midpoint would be the pH of the pure solution, or the neutral solution, which is 7. The internal pH of most living cells is close to 7, or neutral, as we just discussed. Even a slight change in pH can be harmful, because the chemical processes of the cell are very sensitive to the concentration of hydrogen and hydroxide ions. The pH of blood is very close to 7.4, which is slightly basic. A person can't survive for more than a few minutes if the blood pH drops to 7 or rises to 7.8, for example. So a chemical system, or a buffer system, exists in the blood to maintain a stable pH. The presence of substances called buffers allow biological fluids to maintain a relatively constant pH despite the addition of acids or bases. A buffer is a substance that minimizes changes in the concentrations of hydrogen and hydroxide ions in a solution. Buffers do so by accepting hydrogen ions from the solution when they are in excess, or donating hydrogen ions to the solution when they have been depleted. Most buffer solutions contain a weak acid and its corresponding base, which are able to reversibly combine with hydrogen ions.